Today we are continuing again with Unit 6, System can solve a system of linear equations and explain why a system may have no solution, one solution, or infinitely many solutions. Today we're going to focus on a little bit more substitution, and we will run into some that have no solution, one solution, infinitely many solutions. If you are learning at home today, when this video ends, you're going to send a picture of your notes. If you're in class, you're simply going to show the teachers. We're going to talk about first the three things that can happen when you draw two lines on a graph. The first thing is that they can cross. And so that's what we've been working on. We're used to that. You can get one solution. Please take notes. One solution is where they cross. So this is the one solution, and it is an ordered pair, which is the point of intersection, an ordered pair x, y. If you are doing it by paper and pencil, which is what we are working on this week, you will be able to solve for x and y, which is the second kind of solution that you could get is no solution. I have two lines. These lines are parallel. They never intersect. They never cross each other. This crosses. That's the solution. These never cross. So there is no solution. You would actually write the words no solution. Again, if you're doing it algebraically, paper, pencil, which is what we're focusing on now with the substitution method, you're going to be working along and you'll lose the variable, and you'll end up with a false statement. And by a false statement, I mean something like this. You'll be working along and you'll end up with something like 3 equals 8. Nope, that's not true. You will end up with a false statement, and it won't even say 3x equals 8. It'll just, your variable will be gone, it'll be lost, and you'll end up with a false statement. In this third picture, something that you would actually write on your paper if you had this situation is you would write the words infinitely many solutions. You can't just stop in the middle of the work when you lose the variable and expect your teacher to know which one of these it is. So if you lose the variable and you end up with a false statement, you need to write the words no solution. If you lose the variable, but you end up with a true statement, such as 0 equals 0, or 5 equals 5. If you end up with a true statement, you need to write the words infinitely many solutions. What you cannot tell from this picture is that this picture also has two lines. There was a green line here, and the blue line graphed exactly on top of it. That means they don't just intersect in one place, they intersect everywhere. When they intersect everywhere, you'll get a picture of one line on top of each other. That's infinitely many solutions. If you're doing it paper, pencil, like we're doing it this week, you'll lose your variable and end up with a true statement. And that is infinitely many solutions. Now, guys, I have had some situations where students solve this kind of problem differently from me, and they don't lose their variable, but they end up with something like x equals x. Well, if you end up with something like that, you really do, you could lose the variable by putting the variables both on the left, minus x on this side to get it over to here, minus x. That does end up with 0 equals 0. So you really do lose the variable, but if you end up here, you know that's going to happen, and you can go ahead and write the words infinitely many solutions. But you do need to write the words. You cannot just leave 0 equals 0 or x equals x. You have to write the words. So let me show you what this looks like. We're going to do 3 problems. So on this one, y equals 6x plus 21, 7x minus 5y equals negative 13. So this one already has y isolated. So that is what I'm going to substitute in the place of this y. I have what y equals. I don't know if it's 2 or negative 3 or 8 or 17, but I know that y is 6x plus 21. So I'm going to take 6x plus 21 and put it in the place of this y. So it's going to look a little bit more challenging than what we did the last couple days. So remember, I'm going to take this 6x plus 21 because it equals y, and I'm just going to replace this y with that information. So 7x minus 5, and you need to put big parentheses because you're going to put a big phrase in there, equals negative 13. So 7x minus 5y equals negative 13. 7x minus 5y equals negative 13. In the place of y, we're going to put 6x plus 21. Now, guys, this brings us back to the beginning of the year when we practiced using the distributive property. When you have a number outside the parentheses, you're going to multiply that number by both things in the parentheses as your first step. So this is a negative 5. Negative 5 times 6x is negative 30x. And negative 5 times 21 is negative 105. But don't forget, everything else gets brought down. So I'm going to bring down negative 13, and I'm going to bring down 7x. After you do distributive property, you're going to combine like terms that are on the same side of the equal sign. So 7x and minus 30x are on the same side of the equal sign. So they can go directly together. 7 minus 30 is negative 23x. But I still have my minus 105 and my equals negative 13. Remember, we like to get the variable on the left-hand side of the equal sign, and it already is. We like the constants to go to the right-hand side. So we're going to move this minus 105 away by doing plus 105. It cancels, and we plus 105 on the other side of the equal sign. Now, I am having trouble with my pen writing. Grab your calculator and do negative 13 plus 105. That's very sloppy, but that's a plus 105. Negative 23x comes down, and negative 13 plus 105 is 92. Then to get x by itself, we divide by negative 23 on both sides. And those cancel, and I have x equals negative 4. Again, guys, grab your calculator. 92 divided by negative 23 gives me x equals 4. Am I finished? No. I started out with two problems or two equations together, and in those equations, I did not know x, and I did not know y. So I have done some substitution. All that work, all that you've been listening to me talk about, all I have so far is that x equals negative 4. I still need to get y. But remember, the name of the game is still substitution. So I can substitute again. I just did substitute. Right here, I put 6x plus 21 in the place of y. But I'm going to substitute now negative 4 back up here in the place of x. So y equals 6 times negative 4 plus 21. Y equals negative 24 plus 21. Y equals negative 3. So my solution, x and y, in order in the ordered pair, negative 4, negative 3, x, y. Don't forget, you can check your work. So when you have an ordered pair, x, y, this is one solution. You do not need to write the words one solution. This is the one solution. Now let's look at another one. On this one, I am going to use substitution again. And the reason I know substitution is a good method to use is because at least one problem, and that's the top row, has y isolated. If they both said y equals, I would suggest using a graph. They don't both say y equals. So substitution is my choice. And I'm going to take this negative 4x minus 15, which equals y, and I'm going to replace that y. One of the problems that I see students do is while they're getting ready to substitute in, which is what I'm doing, they accidentally copy some stuff from the bottom and some stuff from the top. Don't do it accidentally. Do everything on purpose and carefully. So this is my bottom equation. Negative 4x minus y equals 15. Negative 4x minus y equals 15. In the place of y, I have a whole expression. So negative 4x minus 15. So I'm replacing y. I'm substituting it. There is an understood 1 right here, negative 1 to distribute. So I'm going to take care of that. Negative times negative, 1 times 4 is 4. And then negative times negative, 1 times 15 is positive 15. I still have the rest of the problem to bring down that I haven't worked on yet. And this needs to be a plus sign since that is a positive 4x. Now, here's the deal. I have negative 4x plus 4x on the same side of the equal sign. So I'm going to combine those together, and that's actually 0. So 0 plus 15 equals 15. What's 0 plus 15? 15 equals 15. Now, that's true, but I lost my x right here, canceled itself out. So remember, if you lose x, but you get a true statement, then you stop, you go back and check, you do everything right. And when you're sure you did everything right and you have a true statement, you don't just stop and go to the next problem. You do have to write these words to let your teachers know that you understand that this means anything. Infinitely many solutions. You can put anything in for x in the top equation to get y, and it'll do this exact same thing in the bottom. Right, taking a look at this problem, this is another good candidate for substitution because remember, if we're going to do substitution, we're going to look for an x or a y that has been isolated. So this y is already isolated. That means I can use it to replace this y with 2x plus 1. So when I get ready to do that, negative 6x plus 3y equals negative 4. I just rewrote this equation, but instead of y, I left an open space where I'm going to put the expression 2x plus 1. Then I'm going to go through my steps. I'm going to distribute. So 3 times 2 is 6x, and 3 times 1 is 3. And then I still have the rest of the equation that I haven't worked on that was not part of the distributive property to bring down. And this was a positive 6x, so plus 6x. Then I want to make sure my variables are all on the left, and they are already on the left, but I need to combine like terms. Negative 6x plus 6x, that's actually 0. So 0 plus 3 equals negative 4. 0 plus 3 is 3. So 3, no, that does not equal negative 4. So remember, when you've done your work and you double check that everything has been worked out properly, that you did not mess up, your x's, your variables have canceled, but you have a false statement, then you will write the words no solution. What this is telling me is I could pick an ordered pair and plug it in for x, y on the top problem. It would not match on the bottom equation. So they would not have any place that they would have the same x and same y. You do have to write the words no solution. You can't just stop working and say it didn't work out. You need to know that that means no solution. So at this point, I have done 3 examples, and the 3 examples go along with the notes that we took earlier. In the notes, we wrote that there would be 3 types. Oh, goodness, it went too far back. 3 types of solutions. One solution, that's where you get an ordered pair. No solution, when you get a false statement, and infinitely many solutions when you get a true statement, but your variable has been lost or has canceled out. So this first one, We were able to solve for x and y, so we got an ordered pair, -4, -3. On the second one, our variable canceled out right here, but we had a true statement, so you write the words infinitely many solutions. On this one, our variable canceled out right here. We had a false statement, so we wrote no solution. Make sure your notes are organized and neat. And if you are an at-home student, you are going to send a picture through Remind or email showing us your notes for today. And if you are at school, you will simply let us see your notes as we walk around and monitor the classroom. We'll see them while you're there.